Now we are in chapter 2, multivariable optimization. In this chapter, we consider the multivariate optimization problems. Many problems require the simultaneous consideration of a number of independent variables. Let me take a function y equal f x1 and xn. This is a function with n independent variable and on a subset S of the n dimensional space Rn. So we wish to find the maximum or minimum or both values of f on the set S. So let me explain this notation first. As an example, let me write y equal x1 squared minus 3x2 plus 10. So this is the function of x1 and x2. Therefore, you can write down this in notation y equal fx1 and x2. So that is the meaning of the notation. Now let me explain how to find the minimum or maximum of this function. So how do we do that? First, get the partial derivatives and then set them equal to 0. Partial derivative of f x1 xn with respect to x1, so set this equal to 0 and go to the second one, go to the third one. Similarly, you can get the last one, partial derivative of x1 to xn divided by partial derivative of xn, set this equal to 0. Now you see we do have n n equations n equations n equation. Then to find the maximum or minimum points, n equations must be solved simultaneously. Then we must also check any points on the boundary of S, as well as any points where one or more of the partial derivatives is undefined. Okay, I will explain this using an example. A manufacturer of color TV sets is planning the introduction of two new products, a 19 inches LCD flat panel set with the manufacturer's suggested retail price of 339 and a 21 inches LCD flat panel set with the manufacturer suggested retail price of $399. The cost to the company is $195 for 19 inches set and $225 per 21 inches set, plus an additional $400,000 in fixed cost. In the competitive market in which these sets will be sold, the number of sales per year will affect the average selling price. It is estimated that for each type of set, the average selling price drops by 1 cent for each additional unit sold. Furthermore, sales of the 19 inches set will affect sales of the 21 inches set and vice versa. It is estimated that the average selling price for the 19 inches set will be reduced by an additional zero point 0.3 cents for each 21 inches set sold, and the price for the 21 inches set will decrease by zero point 0.4 cents for each 19 inches set sold. How many units of each type of set should be manufactured? Write the summary of the problem. They have a factory manufactures color TVs of 19 inches and 21 inches. So we do have two type of TVs. Then we do have cost. It is $195 per 19 TVs and $225 per 21 inches TV. They have $400,000 fixed cost. Then we have suggest price for the 19 inches TV for the $339, 21 $399. Then market impact, average price drops by 1 cent for each unit sold, and average price of 19 inches reduces additional zero point 0.3 cents for each 21 inches sold. The average price of 21 reduces additional zero point 0.4 cents for each 19 inches sold. So then, what is the question? They are asking how many units of each type should be manufactured. This is unconstrained optimization problem. So we can use the 5 steps method that we learned in the chapter 1. In the first step, we should define our variables and assumptions, then objective. Let me define the variable first. So we know we do have two type of TVs, 19 inches and 21 inches. So we need two variables. I take S and T. Then average selling price of both TVs, 19 and 21, P and Q respectively. And capital C is the total cost of manufacture, and capital R is the revenue or income from the sale of TVs. Then P is the profit. Okay, next let me discuss assumptions. Okay, here simple P, average selling price of 19 inches TV. So let me write down an equation for the P first. So this equal, we know MSRP price of 19 inches 339, but if you go to the problem, you see it says average price drops by 1 cent for each unit sold. Okay, it means it must be subtraction. Why? It is a drop by 1 cents. 1 cents means 0.01. It is for the one unit. How many unit we sell? 19 inches TV. S. Therefore, you should multiply by S. And then again go back to the problem. It says average price of 19 reduces additional zero point 0.3 cents for each 21 sold. Okay. Now go to the T. T is the number of 21. So they drop again, therefore subtract 0.3 cents. Therefore 0.003 T number of 21 TVs. Okay, so this is the P, average selling price of 19 inches TV. Right. Then go to the second one, Q. I will write down an equation for the Q. Q equal average selling price of 21 inches. So what is the MSRP? That is 399. We know that 399. But again same thing. The average price of 21 reduces additional zero point 0.4 cents for each 19 sold. Therefore 0.004 and S. I mean this, you see this number of 19 sold, therefore multiply by S, and again same thing, average price drop by 1 cent for each unit, therefore subtract 0.01 T. T is this one, you know that. Okay, now we do have an equation for the average selling price of 21 inches TV. Then go to the revenue or income. What is the income? Income should be selling price multiplied by number of TVs sets sold, right? In the both cases, in 19 and 21. Therefore, first think about the 19 inches uh, TV. So it is P. So therefore, P multiplied by how many TVs we have? S, number of 19 inches. Therefore, multiply by S. Then plus same thing for the 21 inches TV. So selling price of for this 21 should be Q. Then number of TVs of 21 T. So that is the this is the income uh, by selling 21 inches TV. This is the income by selling 19 inches TV. Therefore, add them together, then you will get the revenue, which is income. Then go to the total cost. Total cost. See, total cost equal. How do we find the total cost? Go back to the problem again, and we know 400,000 is the fixed. You know, cost for the 19 TVs 195. Therefore, add 195. How many TVs they have? S number of TVs. Then similarly for the 21 inches, it is 225. 225. How many TVs? T number of TVs. Therefore, add T. Then let me write down for the profit. How do we write the equation for the profit? Revenue, income minus cost. See, so this is the profit function. Okay, so then we know the R, we know the C, so then we can just plug into this equation. Um, Now we know S greater than equal 0 and also T greater than equal 0. These are the assumptions. Then what is the objective? Objective, you already know that, maximize the profit. Maximize the profit, which is P. Thing we discussed so far is the step 1. Step 2 is to select the modeling approach. We will solve this problem as a multivariable unconstrained optimization problem. Unconstrained, unconstrained optimization problem. Then step 3. Okay. Step 3 is to formulate the model using the standard form chosen in step 2. Okay, let me write down first P, we already know. Let P equal R minus C. So you know R, we know R, R is the PS plus QT. You know R equal PS plus QT. So you know the P and Q and T. So we can plug those values and you will get 339 minus 0.01 S minus 0.003 T time S plus 399 399 minus 0.004 s minus 0.01 t time t, then subtract 400,000 plus 195 s plus 225 t. So that is the p. Now y equal p be the quantity we wish to maximize, and also I will use x1 equal s and x2 equal t. So these are the decision variables. So now our problem can be written y equal 339 minus 0.01 x1 minus 0.003 x2 times x1 plus 399 minus 0.004 x1 minus 0.01 or 1 x2 times x2 minus 400,000 plus 195 x1 plus 225 x2. Over the set s equal x1 x2 x1 greater than equal 0 and x2 must be greater than equal 0. So that is the step 3. Step 4 is to solve the problem. Okay, now we have the function f(x1) and x2. You can check the above function. So then what to do, get the partial derivative of this function and set this equal to 0 and solve for x's. Let me explain. So please check your equation under step 3. We have fx1 comma x2. So then I will take the partial derivative with respect to x1. So you will get 144 minus 0.02 x1 minus 0.007 x2 equal to 0. The next one with respect to x2 equal 174 minus 0.007 x1 minus 0.02 x2 equal to 0. So then we do have two equations, 0.02 x1 plus 0.007 x2 equal 144, then 0.007 x1 plus 0.02 x2 equal 174. So we do have two equation and solve for x1 and x2. I will give the x1 equal 554,000 divided by 117. This equal approximately 4735, and similarly x2 equal 824,000 divided by 117. So this 77,043. So these two are the x1 and x2 value. Then we can find the maximum value, which is y equal fx1 comma x2, just plug this value and this value into the equation of fx1 comma x2, then you will get then you will get 21 comma 592000 divided by 39 equal 553 comma 641. Okay, so this is the maximum value. So this is the maximum profit. Maximum value is, or maximum profit is 553,641. So step 5. So what is the step 5? Step 5 is to answer the question in plain English. So for this case, simply stated, the company can maximize profits by manufacturing 4,735 of the 19 inches is this one. You see this one, 4,735 and 7,043 20 of the 21 inches set, resulting in a net profit 553,641 for the year. Again, if you need, uh, the company can maximize profits by manufacturing 4,735 of the 19 inches sets and 7,043 of the 21 inches sets, resulting in a net profit of 553,641 for the year.